So today we will see the last method for solving systems of linear equation, that it's called the graphic method. The name tells us that we will need to draw our specific equations to know the answer. First of all, it's important that we need to know each equation will represent a line in the Cartesian plane. The Cartesian plane is what we have here. And in the Cartesian plane, the important part is that we have two different axes. The x-axis, that is the horizontal one, that is positive to the right, negative to the left. And we have also a vertical axis that is called y, and it's positive on the superior part, negative on the inferior part. So we have like 4 different parts of the graph. That's why we have here number 1, number 2, number 3, and number 4, because the graph is divided in 4 sections. So what's important, it's x, it's the horizontal one, positive to the right, negative to the left. Y, it's the vertical one, positive on the superior part, negative on the bottom part. So how do we know which kind of answer we can get? Because remember, we have 3 answers or 3 types of answers. We can have unique solution, we can have that a system has no solutions, or that we can have infinite solutions. So how do we observe if we have those kind of solutions in a graphic method? Okay, a unique solution will be easy because the lines touch or cross in one exact coordinate. In one exact point, the 2 lines, the 2 equations will cross, and that will represent that we will have a unique solution. When do we have no solution? We will have parallel lines. What are parallel lines? Are those lines that do not touch each other in any point of the graph. That will mean we will have 2 lines that they do not cross, so that's why we have no solutions. How do we know that we have infinite solutions? We will have one line on the top of the other, so that will mean we will see like only one line because both equations will be on the same line. So that will tell us we will have infinite solutions. So how do we do the graph of the equation? It's going to be kind of easy. We will need to have specifically 3 points to do or to draw a little line. And how to know these 3 points that we need? To know this, we will assign random values to a variable, and we will substitute them on the equation to know the values of the other letter. That means maybe I can put values to x and see on the equation what are the values of y that are specifically for those values of x. So let's see some examples to get a clear view of the graphic method. So on this exercise, example number 1, it's very easy. We have the system of equations with 2 equations. So what do we need to do? So first, we can isolate one of the letters. Maybe on equation number 1, we can isolate the x, and it's going to be 1 plus y. So let's see. We can put a little table to do our specific points. Remember, we need at least 3 points, x and y. So we need to assign random values to one of the letters to know the value of the other one. I will assign here the values to y, and we will get the values of x. So let's see. If here I get the value of y minus 1, it's going to be 1 minus 1, it's going to be 0. What happens next? If y has a value of 0, 1 plus 0, it's 1. So x will have a value of 1. What happens if y has a value of 1? It's going to be 1 plus 1. It's going to be 2. So what happens here? We have 3 points. The first one is 0x minus 1 in y, that is this one. We have the other one that is 1 in x, 0 on y. And we have the other one that is 2 on x and y 1. So we will have those 3 points, and we will need to draw our line to get the equation. So we have graph the first equation. It's that line that passes for those 3 points. Now I need to do something very similar with equation number 2. So on equation number 2, I need to isolate one of the letters. X equals 7 minus y. So we can do our little table. Remember, we need at least 3 values, so it's going to be x, y. So what happens with y? Values minus 1, 0, and 1. Of course, we can put any numbers we want. It's going to be 7 minus minus 1. It's going to be 8. Because it's going to be 7 minus minus 1. It will become 7 plus 1. It's going to be 8. When y has a value of 0, x equals 7, because it's going to be 7 minus 0, that it's 7. When y has a value of 1, x is going to be 6. So we have those 3 points. The first one is going to be 8, comma minus 1, that it's here. 8 on x, that means to the right. Y minus 1, it's on the bottom. So that's the point. We will get 7, comma 0, that it's this one. And we will get also 6, comma 1, that it's this one. So we can now draw our line for that specific equation, and it's going to be this line. So we have already graphed equation number 1, equation number 2, and we can see that both equations cross here. That means we have a unique solution because both equations cross there. And how to know the answer is going to be easy. How to know the answer? Okay, we need to know which point is this one. This point is 4 on x. That means x equals 4. And it's 3 on y. That means y equals 3. So the answer in a coordinate way, x comma y, it's going to be 4 comma 3. And that will be the answer. So for solving a system of linear equations will be very similar in every example. We need to draw our 2 equations using 3 points. We need to see where does those equations cross, if they cross, to have a unique solution, and that will be our specific answer. So let's see another exercise. So let's see, here we have a system of equations. Of course, we have equation number 1, equation number 2. So remember, the idea is for equation number 1, we need to isolate one of the variables. X equals 6 minus 3 that multiplies y. After that, we need at least 3 points. X and y. So maybe we can put values to y minus 1, 0, and plus 1. And let's see. What happens with y has a value of minus 1? It's going to be minus 3 multiplied by minus 1. It's going to be plus 3. 6 plus 3, it's 9. So here it's going to be 9. What happens with y has a value of 0? 3 multiplied by 0, it's 0. So x is going to be 6. And what happens with the other one? When with y has a value of 1, it's going to be 6 minus 3, that it's 3. So we have those 3 points. The first one is going to be 9 in x minus 1 in y. So it's here, 9 to the right, 1 to the bottom. The next one is going to be 6, 0, that is 6 to the right, that it doesn't move to the top or to the bottom. The other one is going to be 3, 1, that it's exactly 3 to the right, 1 on the top. So now we can write or draw our equation number 1. So after drawing equation number 1, we need to solve for equation number 2. So let's see. On equation number 2, if we isolate one of the variables, maybe x, it's going to be 3x equals 10 minus 9y. So it's going to be x equals 10 minus 9y, all of it divided by 3. So let's check out. We can make our little table with the values. X and y. So let's see here what happens with when y has a value of minus 1. when y has a value of 0, and when y has a value of 1. Here is going to be a little bit different because we will have fractions in the answer, and we will need to use the division of those numbers to get a specific point, not a fraction, maybe a specific point for when it passes. So let's see. When y has a value of minus 1, minus 9 multiplied by minus 1, it's going to be 9. So 10 plus 9, it's going to be 19 thirds. What happens with the other? When y has a value of 0, it's going to be 9 times 0, it's 0, 10 over 3. It's going to be 10 over 3. And the other one is going to be 10 minus 9, it's 1, so it's going to be 1/3. So looking for the fractions in the graph is a little bit difficult, so my recommendation is maybe we can use the division and look for the decimal numbers that represent those fractions. So those numbers will represent exactly the decimal numbers that we need to have. So it's going to be the first point, 6.33 to the right and minus 1 on the bottom. So it's going to be something like here. Of course, it's a little bit difficult to put 6.33. 3.33, comma 0, it's going to be something like here maybe. And we will have also the one that it's 0.33, comma 1, that it's going to be something like here. So we can make the second equation graph, and let's see the line. So we have equation 1 and equation 2 graphed. If we see, we have parallel lines here. We have parallel lines. They won't touch in any point. So that will mean this specific system of solution of equation has no solutions. Why? Because the specific lines do not cross in no part of the Cartesian plane, so that will mean the system has no solutions. So remember, we can have three different answers: unique solutions if the lines cross out in a specific point, has no solutions if we have parallel lines, or we can have infinite solutions if we have the same line. Let's do another exercise. So let's see, the next example is going to be this system. So remember, we need to isolate one of the letters in every equation. So on the first one, it's going to be x equals y plus 2 minus 8. So it's going to be x equals y minus 6. So we can do our little table. It's going to be x, y. So imagine when having y minus 1, 0, and 1. Remember, we can put any values. So when y has a value of minus 1, it's going to be minus 1 minus 6. It's going to be minus 7. When y has a value of 0, it's going to be minus 6. When y has a value of 1, 1 minus 6 is going to be minus 5. So let's check out. The first point, it's minus 7 in x, that means to the left. Minus 1 in y, that means on the bottom. The next one is going to be minus 6, comma 0, minus 6 to the left, 0 to the top or to the inferior part. And the other one is going to be minus 5, that means to the left, comma 1, that will be here. So now we can make our line. So after that, we need to do the same with equation number 2. So on equation number 2, it's going to be x, well, to be in the correct order that you have it there, y minus 4 minus 2 equals x. That means x equals y minus 6. So if we check out this one and this one, it's exactly the same. So equation number 1 and equation number 2 will be exactly the same. So because we have exactly the same equation, only one line, one on top of the other one, we can say that this one has infinite solutions. And that will be the answer for this specific example. Let's do one last example for the graphic method. So on this system of equation, it's going to be exactly the same. Equation number 1, we need to isolate one of the variables, x equals 10 plus 2y. So let's see. We need to make our little table. X, y, minus 1, 0, and 1. So let's see. When y has a value of minus 1, it's going to be 2 minus 1. It's 2 multiplied by minus 1, it's minus 2. 10 minus 2, it's 8. The other one, when y has a value of 0, it's going to be x equals 10. When y has a value of 1, it's going to be 10 plus 2, it's going to be 12. So we have those points. It's going to be 8, comma minus 1, 8 to the right, minus 1 to the bottom. Then it's going to be 10, comma 0, that is 10 to the right, 0 to the top or to the bottom. And we have 12, comma 1, that it's going to be exactly here. So we have our 3 points. We can do the line of this graph. So we have already the line for equation number 1, so we need to do the same for equation number 2. So it's going to be 2x equals minus 8 minus 3y. That will mean x equals minus 8 minus 3y, all of it divided by 2. So let's do the little table. So x, y. So let's see, when y has a value of minus 1, 0, and 1. When y has a value of minus 1, it's going to be minus 8 minus 3 multiplied by minus 1, it's going to be plus 3. Minus 8 plus 3, it's going to be minus 5. So here it's going to be minus 5 halves. What in the other one? It's going to be minus 8 minus 3, that multiplies 0. So it's going to be minus 8 divided by 2. It's going to be minus 4. And what happens with when y has a value of 1? So on this one, it's going to be minus 8 minus 3 divided by 2. It's going to be minus 11 halves. So let's see. Remember, we need to have, instead of having fractions, we need to put the decimal numbers of those fractions. So those are the specific decimal numbers. How do I obtain it? 5 divided by 2 and 11 divided by 2. So the first one is going to be minus 2.5, comma minus 1. So it's going to be exactly here. The other one is going to be minus 4, comma 0. That is going to be minus 4 to the left, 0 to the up or to the down part. And we have also minus 5.5, comma 1. That is going to be exactly here. So now we can draw the line for our second equation. So we have the line for equation 1 and equation 2. Remember the specific point where they cross. It's going to be this root or the answer solution for this specific one. It's when x has a value of 2 and when y has a value of minus 4. So the answer is going to be x2, y equals minus 4, or we can put it in coordinates. Remember, x comma y, and it's going to be 2 comma minus 4. So we have now explained the last method for solving systems of linear equation, that is called the graphic method. See you next video.